Hello, my name is Lewis Correa Sanchez and I'm a systems engineer and I am currently studying a master's degree in geoinformatics at the Universidad Distrital Francisco José de Caldas in the city of Bogota. On my part, you will have a strong greeting from Colombia.
And it's about the temperature monitoring and forecast systems in remote areas with 4G LTE mobile technologies. Colombia's current situation in forestry has been booming lately, as the media are becoming more and more intense in considering environmental catastrophes. But it is clear that the response times for these calamities are still inefficient in terms of the losses produced by this catastrophe. A rapid assessment shows that the situation in the Department of Arauca in terms of the number of fires is small, but the same amount caused great damage in terms of hectares affected. While in Cundinamarca the number of fires is high, but the number of hectares affected is lower, making it possible to emphasize the urban character as an advantage to act instantaneously the fire is detected. Of course, the urban character is treated from a technological perspective specifically. A more detailed assessment shows that the relationship between the number of fires and the number of terrorists affected per department is closely related, as each fire is causing direct damage to the terrorists in risk areas. Not to prevent the fires, but to act when they are detected in danger category. It immediately causes damage to the hectares of the surrounding area. Method is the representation of the methodology that will allow the development of research. In terms of its most representative components during the management phases and the relationships of the main components associated to the proposed system, it has an objective context, which can be understood as the plan where there will be installation of a physical assembly, which will allow to manage sensorial data flows to to the temperature sensor to bring the notion of the state in which the environment is that you want to monitor and follow up. The system will be able to capture this data flow and apply transformation to its input to have the prediction module based on fusel logic. Using a predictive component can extend the monitoring properly made from reading the flow of information and to follow up the possible states of temperature as the system learns its data entry. With this, the system will reproduce the competent information to its telecommunication module with mobile devices in order to send the information flow to a user through its module technology so that it can consume the information concerning the surveillance and supervision of a potential catastrophe risk area. In the table, it is possible to appreciate the structure of for the data to be handled during the experimental development of the system. This table contains specific aspects about the details that will be taken into account for the presentation of the implementation and results obtained for the eventual analysis. This information establishes how each of the methods and techniques that will allow the monitoring and monitoring of temperature to the system will be performed in the sense presented by the experimentation documented here and the process to be followed to consume the product information. It is necessary to clarify that in the data of capture polarizations, it is a configuration available for the sending of data obtained sincerely by reason of each interval of time, so that the amount of resources devoted for the experiment covers a period in time in that the correct analysis can be provided and thus offer the services developed in the system. In this figure, it is possible to appreciate the arrangement of nodes as an abstraction endpoint, which is the closest thing to the implementation and installation of the software in an application environment. It should be mentioned that the communication flow between the nodes follows a sequential pattern, as the information is traveling from the server to a client. However, it is understood that there is a constant data capture from the microcontroller device, which causes the flow of communication is continuous and provides more appropriate and sustainable use of software. In the same order of implementation, I conceived the construction of a mechanism to achieve the emission by the software system and the reception by the Android customers through the notification that this operating system provides. Of the application on Android. In this figure, the operation established for the creation, sending, and reading of notification is displayed. as the software system is in its monitoring and control work. Within this operation, it is highlighted the assignment of a single token or identifier to each client, which is registered by the server provided on the server side of the software, which then uses the messaging service provided by Google called Firebase Cloud Messaging, who is responsible for sending the notification created from the control and monitoring proposed by the application built. For the transmit antenna, initial parameters. In the equations 1a and 1b, the initial parameters are presented so that it is possible to begin by indicating the desired transmission frequency and the function associated with the transmission of the signal. Main values. In the set of equations 2, the calculation for the APBW and FNPW standards is made. First, with the declaration of assignments to the functions of the proposed signal in the part 2a, and then finding the values for 2 in each standard in the part 2b. Radiation power. In the set of equations 3, the procedure is performed to calculate the expected radiation power for the antenna, according to the initial parameters, so that in the part 3a, the associated declaration is made with the equation of the radiating power in the part 3b. The substitution is made by the initial function of the signal, and in the part 3c, the result associated with the radiative power is displayed after operating on the proposed calculation. Result of the implementation on the developed system in terms of the temperature captures in an experimental field room located in the city of Bogotá, D.C., Colombia during the present year is exposed. In this figure, the temperature values in degrees Celsius can be seen at different times, captured in 10-minute pulsations between registers. It is important to note that the times were taken in negative due to the use of this information as an empirical element to demonstrate the operation of the fusion system later. Of the fusion prediction system initially. You can think of a scheme of functions as seen in the set of equations 4, where determine the antecedent responsibility to the equation for A, determine the present liability to the equation for B, and determine the consequent liability to the equation for C. This proposal will be supported by the fact that the fusion system can be fed with the predecessor and present experimental values, so that it is possible to determine the consequent through a physiologic basic procedure. In the same order of the above experiment, the result obtained from the prediction of the fusion system can be seen in the before figure, by means of the comparison between the functions of real value, xt, and value predicted, xt plus 1, at each of the recorded times in the previous experiment. It is important to mention that the behavior is quite as desired, as the system is fed with empirical values, and in this way, future or consequent values can be offered to the temperature register with respect to a sample of temperature records. In fact, the system can provide prediction values for this field experiment, as can be seen in the table 2, where for the times t equals 0 and t equals 1. The values of x of t and x of t plus 1 represent the real and future values respectively. Example, for the following positive times, after the negative empirical collection, an analogy is made to the behavior of the register's temperature and the prediction to themselves. The first result of the calculation related to the sum of quadratic error obtained from the field test with the physiologic basic prediction system, rather than for service automation systems for the monitoring and supervision of remote areas is an emerging research challenge, whether they are dealt with computational elements for the analysis of forest environments or through the learning of machines using cybernetic automata. In the, in the second table, it is possible to appreciate the sum of the quadratic error related to the experiment by applying the parameter adjustment mentioned above. It should be emphasized the great improvement that leads to the experiment, as the quadratic error has been greatly reduced. Consequently, this aspect would directly place a new milestone for the already developed monitoring and temperature monitoring system, which would increase the reliability of the information provided by all the services exposed. In the right table, is possible to observe the values of the variables that can be improved under a numerical method to obtain an improvement in the index of the quadratic error. That is to say, by means of an algorithm of operational optimization based on the mathematical functions for the data used in the experiment. So, but using the solver mathematical model and of the Microsoft Excel tool, the prediction system must be able to optimize its criteria to have the correct balances when providing an appropriate monitoring and tracking service. The presentation of the temperature monitoring and forecast system has defined the composition of the software development, insofar as it has solved the scope of the project with an implementation of mobile 4G LTE technologies for the proportion of remote computer service, which in turn provided a predictive analysis for system feedback with the intention of providing decision support for high risk areas, measurable through their temperature records. The development of the research software included in the nuances of analysis with previous research works has contributed to a system of refinement in the provision of computer services with the intention of solving a constant problem in contemporary society, to the point that a system that under experimental conditions has surpassed a quadratic error sum at 2.6% sample through the experimental implementation of the monitoring and supervision system. The information management procedure has been observed to the point of changing a quadratic error sum of 2.2085% to a value of 0.0013% of the tables 3 and 5 respectively, which looks at the control of variables on the software model, would support any practical scenario where it is installed. You can find me at LCORREAS at CORREO dot UDISTRITAL dot EDU dot CO.